So thank you. It is extremely intimidating to be in front of this illustrious group, but an enormous honor. So I thank the organizers for inviting me. It's also an enormous because it's so rare in one's career that you get the opportunity to thank people who've been so important to you in the development of your career and developing your life. So Aravind, thank you in so many ways that for those of you who know my work, you know that so much of my work has been inspired by Aravind's thinking, by Aravind's insights. I would not have come to Penn without him. I was all committed to go elsewhere for graduate school, and then on the day of my graduation arrived at in my mailbox in college a letter saying that I'd been admitted without funding, and that I came to visit Penn and went around, and then at the end of the day, Aravind said to me kindly, well, wait a couple days and we might have some money for you. And so miraculously, he was able to find funding for me, and I came here, and it was important to me also personally that this is where I met my wife, and so had an enormous effect. And so I've followed this not only intellectually, but as I commented to Mitch, I've decided more recently that I should follow in my hair fashion as well. So I've been pursuing that line as well. Okay, so the title of this presentation is As Simple as Possible, but No Simpler, something that's sometimes been called Einstein's razor. So what I want to do before I talk about that in a technical context, I want to echo some of the things that a lot of people have said already this morning about how that razor applies to Aravind in his sort of professional capacity, not in terms of the intellectual work, but, well, not in terms of the intellectual output or the scholarly output, but in terms of his interaction with people professionally. So certainly as an advisor, he takes this very what might be perceived on the outside as taking the most simple approach to advising, not imposing structure on one's advisees, but letting them find their own questions and their own paths, and letting students delay quite a bit, such as I did, in choosing a dissertation topic. I remember one of the students who entered with me, Ramesh Subramanyam, who decided not to pursue work in computational linguistics, tells a story that he went into Aravind's office the first week of graduate school and said, okay, so tell me what I should work on. And Aravind looked at him and scolded him and said, look, if I knew what you should work on, I would do it myself. So this is beautiful, right? And this is really the key of how Aravind has treated his colleagues and his graduate students, giving us the space and the respect and having confidence in us to let us find our own paths. And I've noted, in my 20 years as an academic, as a professor now, I've seen that's not always the easiest thing to do with students, especially when you're not so sure that they're going to find that path. So it's an enormous, I have enormous respect for his ability to do that. Also, the simplicity with his students in his interactions, as those of you who've had many meetings with him, you know that there can be moments where one just communes, and there can be these moments of space. And if you grew up in New York, as I did, one is not very comfortable with there being a lot of empty pauses in a conversation. And it took some time to get used to realizing that I should not just flail away and just fill this space, that there was something to be gained from just communing for a moment. And I think this was real genius, and I have enormous respect for it. So that's simplicity in advising. As well, he was an enormous cultivator of cognitive science and computer science at Penn. And he really was remarkable in establishing a computer science and cognitive science environment, as we've seen, as we heard already from some people here, one which is not dogmatic, so simple in there not being a particular dogma that we're imposing and saying you have to abide by this particular way of thinking, but not too simple, so one which cultivated extremely careful thinking. It also seemed to me that when I was a student here, I remember there was the Sloan Lunch, which I guess was the precedent to the ERC's colloquium series, and we all used to go every Friday at lunchtime into the library. And we would go for these wonderful talks, and we'd learn about all sorts of things. And I always thought that that seemed like the simplest thing in the world. You get these people together, and they talk, and so on. It seems like the most obvious thing in the world. And the astonishing thing is that now, trying to get one's colleagues to do that is remarkably difficult. So it looks simple, but it ain't. Finally, as a leader in the field, he has led with the example of his work, which is, as I said, not dogmatic, but really dogged in his willingness to pursue an idea, to take some idea and squeeze it, because out of the conviction that there was really something to be found from it. And finally, as a colleague, this willingness, this simplicity and this just willingness to play, this joy in just exploring ideas and taking them and seeing what one can get out of them, and not having emotional attachment, but really just being able, throughout his career, to being able to get excited about ideas. And I remember just several months ago, we had a conversation on the phone where he was enormously excited about a new idea that he'd had, and I thought, I should be able to do that when I'm at his stage in my career. Okay, so that's my personal recollections. I'll have a thing to say about that at the end. But let me now talk a little bit, some sort of technical recollections. So, of course, the obvious thing that my title refers to is simplicity in grammar. And so everyone here knows about the Chomsky hierarchy, and Chomsky put forward this agenda some time ago that we should think about grammars, as Tony mentioned, in terms of their formal capacity, and we might want to start with the simplest possible system, following Einstein's razor. And so, you might start out at the level of the finite state. And, of course, Aravind was one of the vanguards in that connection, working on a parser which used finite state means to do parsing of English with a interesting collection of folks. Now, as you also know, someone, this young Noam Chomsky, came along and said, well, that's not going to work, right, because the finite state is not sufficiently powerful. Okay, and so you might think, well, we've got to move one step up the ladder, go to context-free, and so we've heard a little bit about GPSG this morning, and then our friend Stewart kindly pointed out that's not going to work either, right? To which Chomsky replied, well, actually, this is a little bit of a historical revision, but to which Chomsky might have replied, we need something else. We need transformational grammars, right? And, there was something very beautiful about that. But as was noted by a number of people, and most prominently the Peters and Ritchie result, showed that, look, these systems are extremely powerful, like Turing machines, basically, and so that they don't really constrain us in any interesting way. Sure, you can use them as a descriptive notational device, but they're not going to, in a sense, tie one hand behind your back and force you into certain conclusions, be able to derive conclusions about the nature of grammar from using those formal systems. And so Aravind had this brilliant, extremely bold hypothesis of mild context sensitivity, as you all know, which was characterized not completely formally, but essentially as the context-free plus a little bit and some other formal properties. And it should support efficient processing. Now, in order to explore this bold hypothesis, and its detailed consequences, one needed to instantiate it. And so Aravind put forward tree-adjoining grammar, as we just heard, and as all you know. And there were two fundamental insights that any student of Aravind's can recite: the extended domain of locality and the factoring of recursion. That is to say that syntactic structures syntax is fundamentally local. It's fundamentally about local relationships. And the degree to which that's not true, that's been obscured, is just because you have ignored the idea that there's recursion that's been introduced. And once you factor that away, everything is beautifully local. Okay? And there's, of course, lots of work in trying to lay this out by a lot of people in this room. And there's some really remarkable payoffs. One payoff has been that this formal system provides a real astonishing point of convergence among disciplines. It really provides a way of doing cognitive science of language by allowing linguists to investigate the detailed syntax of natural language, computer scientists to understand the algorithmic properties or how these things can be applied in natural language processing applications, psychologists to study language processing and acquisition. In addition, from the point of view of the linguist, so I guess I have traded my computer science hat for a linguistics hat, we care a lot about things like making grammatical analyses simpler. So as Tony mentioned earlier, we can see that the detailed properties of things like grammatical dependencies actually follow as theorems from very simple assumptions about these elementary objects, the elementary trees, plus the fundamental way in which the tag system works. Now, there's another kind of implication that tag has that I want to mention and that I think is extremely interesting, which is that essentially what we're doing is if we're doing syntax in a tree drawing grammar, we are doing syntax with one hand tied behind our back. That is to say, it's as we want, it's restricting our analytical options. And that's a sort of a joy for a syntactician because life is hard and there are too many things to choose from. So it's nice when your formal system tells you what the analysis has to be. And it's even nicer when the analysis that it tells you has to be right turns out to have empirical support. And there are quite a number of cases that I've listed here where that seems to have happened. So there, as Tony mentioned, there's this notion of edge dependency, and there are dependencies which are not, and one would expect them to have different properties, and lo and behold, they seem to. Astonishing. Okay, so this is all very well and good. This is work that I'm sure many of you know extremely well. But we might ask, well, is there simplicity beyond syntax, right? How could one want to do anything beyond syntax? I don't know. But if you really believe that simplicity is the desideratum, and you were Aravind, you would look elsewhere. And so Aravind has done remarkable work together with Bonnie, looking at how powerful is the grammar of discourse. What is the complexity of the kinds of systems we need to describe that? Even more ambitiously, to my mind, he's looked at how powerful is the grammar of proteins. Not something that you would have thought would have simple computational constraint, but he's had remarkable results in that area. Somewhat more modestly, I'm a less big thinking kind of guy. One might look at, well, how powerful is the mapping to phonological form, or how powerful is the mapping to semantics? Now, it turns out that the third of these, the phonological form, has been somewhat investigated, but mapping between syntax and semantics from a kind of formal perspective has been a shockingly underexplored. I guess the idea is that our semantics colleagues think that's a really, really hard problem, even to characterize what the heck a meaning is. To do it with one hand tied behind your back, forget it. So they just have not explored this kind of agenda. I asked Barbara Partee once this question, whether she knew of work that looked at formal constraints on semantics, and she couldn't think of a single thing, which, if you know Barbara's knowledge of the literature, is quite astonishing. Okay, so let's think then about what it would mean for the semantics, the mapping between the syntax and semantics, to be formally constrained. So let's think about a mildly context-sensitive semantic. So here I'm going to follow on work by two people who wonderfully are both in the audience, Stuart Schieber and Yves Chabas, who proposed this formalism of synchronous tree-adjoining grammar. So as I'm sure many of you know, the idea of synchronous tree-adjoining grammar is essentially that we've got tag, the system that Aravind so wonderfully defined, and there's going to be a tree-adjoining grammar that is associated with the derivation of a syntactic object, and a tree-adjoining grammar that's going to be associated with the derivation of a semantic term. And these derivations are going to necessarily be isomorphic. So we're going to have a pairing. The elementary objects are going to be a paired syntactic structure and a semantic structure, and we'll have isomorphic derivations. So how's this going to work? Well, if we've got a structure like the one there, accepted, that has the syntax of a transitive verb. Its semantics is some little term in some typed logic. And now we have Obama, who might be a DP or noun phrase for those who like those sorts of things better. Obama is an individual of type E. And again, on both sides of the grammar, we're going to do substitution into these linked nodes. We'll do the same thing with the prize, and we can substitute into that object position and get Obama accepted the prize. Now, as I'm sure many of you know, this treatment has also been applied to the sort of meat and potatoes of semantics, that is to say, quantifiers. And the proposal due to Aravind and Vijay Shankar and Yves and Stuart and Laura Kallmeyer and Maribel Romero was to think about quantification in this way, but to make the semantic object, the elementary semantic object, slightly more complicated, that it involves multi-component adjunction. That is to say, we've got, is one of these buttons, is this? Oh, that's cool. I never use these things. So we've got two components in the semantic object. We've got what we can call a sort of operator component that encodes the quantifier, and we've got the nuclear scope, or the variable component of that elementary tree. Okay. So to derive Obama considers every proposal, what we're going to do is we'll have the Obama considered structure, and we will substitute every proposal, the object in here, and we will take the every proposal, we'll substitute the variable into the object position, and the operator will adjoin at the top, giving rise to what we would expect, that kind of structure. Okay? So this is really interesting, and a lot of the work in the tag semantics literature, thank you, has been essentially saying, look, we can do it. But I think one might want to ask even harder questions. Okay, so say, if things are done this way, what does it actually predict? What kinds of things would we expect quantifiers to look like if this is the kind of representation that quantifiers have? So one immediate payoff is in a phenomenon called split scope. So these German sentences, du musst keine Krawatte anziehen, which means you must no tie wear, in word-to-word translation. What's interesting about that sentence is that if you think that the negative quantifier no is something like a negation and an existential does not exist, this sentence has the interpretation where those two components of the meaning of the negative quantifier can actually span around the modal must. So it can mean, it can get the scope not, must, exist. So this means you don't need to wear a tie. Okay, remarkably. Now, what's really interesting about the tag proposal about how we ought to represent quantifiers is that this is very trivial to represent. So if you just say that keine Krawatte is associated with a three-part tree where we've got two operator components, one involving negation, one involving existential, and the variable, so long as we have two places to adjoin these components, let's say at this node above the modal and at this node below the modal, we can very, very simply get that. Essentially, it's completely predicted that this should be a normal sort of thing in the languages of the world. From the perspective of usual generalized quantifier theory, this is a real puzzle and requires you to bend over backwards. So this is rather astonishing. Now, we're looking at a constrained system. Tag imposes lots of constraints, and so one might wonder, oops, wrong direction. Yes. One might wonder, have we gone too far? Is this notion of multi-component tree adjoining or tree local multi-component tag sufficient? And as been pointed out again by some people in this audience, there are cases which are problematic. So cases like Mitt courted 3 people at every fundraiser. So we want to have a derivation that looks like this, where every fundraiser as an argument of the preposition is going to combine there, and then that thing is going to combine in with courted. The problem is that we want every to take scope over 3. And if we try to do that in a kind of the most straightforward way, we've got at with this kind of structure, we've got every fundraiser of this sort. We can do the syntactic substitution, no problem, but if we try to do the semantic combination, the variable has a slot to go, but the quantifier doesn't because there's no T node to adjoin to. We can hack this in various ways, and we can perhaps move to more powerful frameworks such as set local tree adjoining grammar, or we can use vector tree adjoining grammar. But the move to these alternative frameworks is to untie our hand, is to say we're not going to fully embrace the consequences of our theory. And so the question is, well, if we try to keep things as simple as possible, might there be a way of dealing with these phenomena that actually might tell us something interesting about the nature of quantification? And so I think there is. And what I want to do is we should rethink this asymmetry that we've been assuming between the representation of quantificational elements on the one hand and predicative elements on the other. So quantificational elements, as we've seen, have been associated with this kind of operator component and the variable component or the nuclear scope component. And predicative elements are associated only with a scope. Okay? So the proposal that I'm going to make that I've been exploring with my postdoc Denis Storoshenko, who I guess is, in a certain sense, Aravin's grand student, is that we should actually think that there's a parallelism in the semantic representation of these things, of both predicative elements and quantification elements. And what I mean is something like this, that a verbal tree chorded is going to have the chord predicate in it, but its argument positions are not going to be filled by substitution. Rather, they're filled by variables. So that's the nuclear scope, if you like, of the predicate chorded. And there's going to be this other component, which we can think of as analogous to the operator component of the quantifier, where those variables are lambda bound, and the arguments are going to be substituted that will saturate those lambdas. Okay? Now this, in a certain sense, feels like a trick, right? You can do the same thing with at. It's just the same trick. Now this feels a bit like a trick, like what have I done? Well, it makes all the difference in the world when we get at cases like Mitt courted 3 people at every fundraiser, because now we can do the combination there, and we can now do both the substitution and the adjunction of this into this scopal component. And things will work out fine, and we can get all the scopes that we want, okay? So that will give rise to that structure, okay? Now, it turns out that this solution generalizes to a number of other problematic cases that have been pointed out in the literature and have motivated a move to a more powerful system. But again, is this just a trick? We would like it not to be. So, 0. I have 29 seconds according to this. Okay. I'd like to say the answer is that it's not, that actually we do learn something profound about natural language scope from this. And this has to do with some kind of constructions that one finds in American Sign Language. So it turns out that in American Sign Language, there is a class of verbs that shows agreement with their arguments, but the agreement is with respect to the quantificational properties of the argument. So the verb give can be modified with exhaustive, and so this sentence means, I gave each woman a book. And the quantificational force is associated with the verb give. You can get a collective interpretation with a different marker on the verb, right? And you can get yet other kinds of quantificational interpretations with different agreement elements. Now, for those of you who worry, this is not unselective binding because it's associated with specific argument positions for the 3 of you in the audience who care about that sort of thing. Okay, so how do we represent this? Well, it's actually quite straightforward how to represent this sort of thing, right? Well, now we're going to say we've got a give elementary tree. Here's the operator component of the give elementary tree. But instead of those operators being lambda operators as they are in English, we can have in ASL quantifiers that are going to bind those variables. And what this is saying then is that the arguments in ASL are of a different semantic type. They're going to be of type ET, which might be plausible. Okay, so it turns out that this relative scope the relative scope of 2 arguments can also vary lexically. Let me skip that. And we find it in other languages other than ASL, otherwise Mitch is going to kill me. And so what's interesting is one doesn't have to look at languages, these Australian Aboriginal languages or ASL. One can look at even more obscure languages like English. There may be cases where we want to do this for English as well. So there are these predicates that Roger Schwarzschild has called stubbornly distributive. So the boxes are big, right? Can only mean that the individual boxes are big. It can't mean that I've got a pile of boxes and that pile of boxes is big, right? Sort of seemingly odd, right? Because you might have thought, well, why not? That's a possible meaning. And so it's possible that these predicates might be associated with these quantification elements. Okay, so it turns out we can't do everything. So this situation, there are going to be scopes that we can't get out of this system. And in a certain sense, this parallels the kind of situation we find in scrambling that Aravind has discussed. And so the question is, where are those borders? Now, I want to close with one thing, having gone 2.5 minutes over, which is to say something more personal. So Aravind, as you know, had a poster in his office of the deity Ganesh. And I think you had a computer who was once named Ganesh. Is that true? Yeah. And so I never thought much of this. I thought, well, it's an interesting cultural reference. I don't know anything about Hindu deities. And so and thankfully in graduate school we didn't have Wikipedia, so one couldn't find these things out. But for preparing this talk, I decided I was going to look up what Ganesh was. And it turns out that Ganesh is the placer and remover of obstacles. And I thought that was a really beautiful metaphor, because in so many ways that is what Aravind does for all of us, right? He's been crucial in removing obstacles by getting things out of our way to allow ourselves to contribute to this scholarly community. But he's also a placer of obstacles. By encouraging us to study constrained systems, he says that by placing obstacles appropriately, we can hope to understand the nature of language in a deeper fashion. Thank you.
There's time for one very brief question and one very brief answer. That's too brief. It's unanswerable.
Well, I'll show you one more thing, which is, so I also found out in my Googling that there's this image that one can find on the web of Ganesh and the various aspects of the symbolism of representations of Ganesh. And I thought a number of them were extremely interesting. So I encourage you to look at that. Thank you.